we're going to begin Chapter 8, which is further applications of trigonometric functions. In this section, we're going to be looking at a couple of laws, the law of sines and laws of cosines, and then we're also going to later explore polar coordinates, although in this video, we're going to focus on the law of sines. So the law of sines is a nice law that we can use. It's actually quite handy when we want to try to figure out the angles or the sides of a triangle that's not right. So an oblique triangle. So given a triangle with opposite sides labeled in this way, so usually you'll have Greek letters for your angles. Some textbooks may have capital letters instead of Greek letters for their angles, but it's usually one or the other. And then we'll have lowercase letters for our sides. And you might observe that the angle, so alpha, corresponds with side A, beta, or sometimes capital B, corresponds with the side lowercase b, and then gamma, or sometimes capital C, corresponds with side lowercase c. So there is a little pattern there, and we know that according to the law of sines, that we can use proportions in order to figure out a relationship between the angles and sides. So the law of sines states that the sine of alpha divided by A is equal to the sine of beta divided by B is equal to the sine of gamma divided by C. And you can say the same for the reciprocal. So if you take the reciprocal of all of these, you can also set them equal to each other. So it's just letting that the proportion of the angle to its opposite side, they're all equal to each other. And we can use this information in order to figure out missing angles or sides in a triangle. So let's take a look at an example. So what we're going to do in this example is solve for two unknown sides and an angle. And it's saying an angle side triangle, but the truth is it doesn't really matter what type of triangle we're dealing with. I like to think of approaching this as a Sudoku puzzle. So we're given some information, and our goal is to make sure that we have all angles and all sides in the end. So whenever you see solve, and here they're saying solve for, they're telling us exactly what to solve for. Sometimes you just might see the words solve the triangle. So what that means is make sure we know all of the missing angles, or we know all of the angles, may not be missing, and all of the sides. And here we do have some congruency marks here letting you know that, each of these are unique. So in order to do this, of course, we can use our law of sines, but we can also use what we know about the angles of a triangle, right? So I see right here, and I'm just going to observe my information. I have information about alpha and gamma, and I can even write this information on the slide. So let me start. So we see that alpha is 50 degrees, and we see that gamma, let me just move down, gamma is 30 degrees. So we're going to write a 30 right here. And also from this triangle, we have information about this right here. It's not labeled, but it's opposite alpha, so this must be side A. So we know that side A has a length of 10. So I can fill in that information as well. So my goal is to figure out, I need to figure out beta, B, and C. Now, I have two angles already, and I know that in any triangle, the sum of my angles must be equal to 100. And right here, I already have a 50 and a 30. And I'm just going to change my color just so it's clear what I know and then what I'm finding. So I know if 50 plus 30 plus beta is equal to 180. And I already have 80 here, right? So this one right here must be equal to 100. So I'm just going to write this rule down. I know alpha plus beta plus gamma is equal, that's really bad, gamma is equal to 180. So we have beta. If you substitute, beta must be equal to 100 because we already have 80, right? So I'm going to go up here and I'm going to write my 100. So 100 degrees. So I found all of my angles, and I can even on this, let's see, I can put my 100. I can label my triangle as well. I like to do both. I'm very visual. So I'll put my 100 degrees in my little figure. Now I have to figure out B and C. Now, in order to get B and C, I can turn to my law of sines. I have a lot of information. I know alpha and A, so that's great. Because once when I know this ratio, I can actually use this information to find all other ratios. So I can use the idea, I'm going to start and use the first portion of the law of sines. So A over sine alpha, sine of alpha, and I can make this line a little bigger, is equal to B over sine of beta. Right, so I'm going to rearrange this equation. I'm looking for B, so I want B on one side by itself. I know some students love to plug in numbers because you hate looking at these symbols here, but I would caution against plugging in all the numbers first, just because if you start plugging in the numbers and calculating, then you might get a rounding error. So I wait to the very last minute to plug in my numbers. So to get B by itself, I can multiply, right? I'm dividing by sine of beta. So the opposite of that, to get rid of this, I need to multiply both sides by sine of beta. So when I do that, I'll get sine of beta times what we already had, A over sine of alpha. Now imagine if you're typing, you're probably going to have to use your capital letters. That's probably why a lot of textbooks use it too, because on the keyboard, you can't quickly get these Greek letters. Is equal to B. So now that I have everything set up, I can just substitute what I know, right? So I have sine. I'll pause and do that quickly. So just to save time, I went ahead and wrote out the solution. So we started, of course, with the ratio, as I said, and I went ahead and rearranged the equation. So I did sine of beta times what we had on the left-hand side. That's all I did is equal to B. And I substituted the numbers, put this into my calculator, and my final answer was 12.86. And we are asked to give it to the nearest tenth. So up here, my final answer would be is 12.9 if I'm going to do it to the nearest tenth. So I could put 12.9 up here. And then for part C, in order to find side C, not part C, I did something similar. So I took the ratios and I took the two pairs that I needed. So I already had my A in sine alpha, and I'm looking for C, so I took this ratio as well. Notice that although I know this information, I calculated it, I'm going to go back to my original data just in case I made a mistake. I like to use as much original data as I can, because if I make a mistake here, then I can make a mistake here. So I just go back to original. You could use the other one if you really wanted to. It would be mathematically correct. So I set up the ratios. Again, I get C by itself by multiplying both sides by sine of gamma. And then after that, I have essentially C by itself. So I didn't write it, but I could put C is equal to, right? To make it very clear. And then this is the equation I found. I substitute all my values that I know, and my final answer is 6.53. If I'm going to round to the nearest tenth, it's just going to be 6.5. So now I have all three angles, all three sides. I've solved a triangle. So up next, you're going to have an opportunity to try one on your own. So I'm just going to move over to the next slide. And let's clear this screen. So now you're going to solve your own triangle. So again, you're just to solve the triangle to the nearest tenth. You're going to find your alpha, beta, gamma. Make sure you have all three angles, all three sides, and you're going to use that law of sines in order to find all three sides. I'm now showing a solution to this your turn, so to this example. So I started off by just writing down all of the information that I have in the triangle. So I just filled in 98 for alpha, 43 for gamma, and 22 for B, for my side B. And then I first found my angle. That's usually the easiest thing to do, especially when you already have two. So I just went ahead and used the idea that all three angles sum up to 180. So 180 minus 98 minus 43 gives me my 39 degrees. So I now know that beta is 39 degrees. I can then use that information along with my ratios to find sides A and C. So notice here I did have to use some information that I calculated, but I'm quite confident in this calculation because I know I can subtract pretty well. So I was willing to use this. I know I try to avoid it when I can, but sometimes you can't avoid it. I did alpha over sine, A over sine alpha is equal to B over sine beta. And I got A by itself by multiplying both sides by sine alpha. And then after that, I substituted my numbers in, put it into my calculator, and found that side A is 34.7. So I filled this information in. And I did the same thing to find, or something similar to find C. So I used a ratio that contained what I was looking for. So C over gamma is equal to A over sine alpha. Oh, actually, I'm sorry, I used this one, B over sine beta. I just wanted to stick to the same one because I'm just more confident in this information. Then I rearranged the equation to get C by itself. So that means I had to multiply both sides by sine gamma. So I ended up with B over sine beta times sine gamma, and I substituted all the numbers that I knew already for my B, beta, and gamma, put that into my calculator, and I found that C is equal to 23.8, and I put this number right here. So the more you do this, you're going to see that it's not too bad. It's kind of like a Sudoku. Like I said, we're just trying to find the missing numbers as we go. I use any geometric facts that I happen to know. I can't always use this. Like if I only have one angle, that may not be possible. But we can use this law of sines to find sides of the sides of a triangle and our angles, but we do need at least three